So what we're going to do right now, we're going to wrap up the nervous system by going back to the actual system itself. Okay? So, what's the central nervous system? What's the central nervous system? We talked about how the nervous system works, right? We focused on neurons and we looked at three things. One is how a neuron works, how a neuron communicates with other neurons, right, through synapses, and how some examples of how neurons are triggered, right? Now we're going to look at the system itself. So, what's the central nervous system? Right, brain and spinal cord, okay? Can you give me an example of a famous actor who had a spinal cord injury? Died, I can't remember when he died. He died a little while ago. And he played the role of the first Superman. It's before your time, eh? You ever hear of Christopher Reeve? Yeah, he was the first Superman. He injured his spine while I believe it was a horseback incident. Fell off a horse and he broke his back. So the central nervous system is the brain and the spinal cord. What comes out of the spinal cord and the brain is what's called the peripheral nervous system. Okay? So the peripheral, what does periphery mean? Periphery means on the sides. Okay? Peripheral vision means like vision on the sides, right? So the peripheral system, here's actually, this is how it's divided. So here's a nice little, so you have your central nervous system, and then the peripherals, what comes out of the central nervous system. And then it's divided into what's called the somatic. Now, the somatic is what you can control. Okay? So like think about lift arm, move leg. Okay? Those are things that you can control. That is the somatic nervous system. And you could see the neurons are myelinated. They're quite long. And the chemical that they release, the neurotransmitter that stimulates the skeletal muscles is which neurotransmitter? It's acetylcholine. Now, the autonomic nervous system is the system that you don't control. Okay? So somatic is what you control. The autonomic is what you don't control. What would be an example of something in your body that's controlled by the nervous system or regulated by the nervous system that you don't control? Like you just do it. Yeah, respiration. You know, I mean, you could if you want. You could start. You know, you could force yourself to breathe quickly, but you don't really think about, oh, you know, I should breathe a little bit more right now. These are things that just do, right? Blood pressure, heart rate. Those are things that you don't really control. So they're under the regulation of the autonomic nervous system. Now, there's two branches, and this is going to start to sound familiar to you, okay? There's one branch called the sympathetic division, and there's another one called the parasympathetic. And that's what's being illustrated here, okay? If you look, the sympathetic releases adrenaline, epinephrine and adrenaline are the same thing. The parasympathetic releases acetylcholine. These two systems are antagonistic, so they do the opposite of each other. The sympathetic is what we studied in the stress response. Okay? I didn't call it sympathetic, but it's one of the things involved in the stress response. Remember in the stress response there is we looked at the branches of the nervous system. So the system that was involved in that stress is called the sympathetic system. So it's on the right. So what it does is in a stress response, it releases adrenaline, and the adrenaline has certain effects. So what do you think the effect would be on the adrenal gland, for instance? What do you think it would do? It would promote the release of what? Adrenaline, right? What would it do to your heart? So the sympathetic releases adrenaline. What would adrenaline do to your heart rate? It would increase it. What about your lungs and your breathing rate? It would increase it. What about salivation? Yes, very good. So on the right, we have the fight or flight response. Okay? Which is what we looked at in the stress response. Remember, in the stress response, you want to raise sugar levels, right? You want to raise your heart rate. You want to increase blood flow to certain things and decrease blood flow to other things. So on the right is the fight or flight response. On the left, we can call it the rest and digest. Okay? On the right, fight or flight. On the left, did I say it right twice? On the left is the rest and digest. So this is rest and digest. Whatever happens on this side is the opposite of what's happening on that side. So let's think about this for a second. Digestion. Do you want to increase saliva output or decrease saliva? You want to increase it. So on the left, you would increase salivation. On the right, you would decrease. I don't know if you noticed that, but when you're really stressed out and you're in a very stressful situation, you ever notice that your mouth goes really dry? Now you know why. Because salivation is being inhibited by adrenaline. What about your eyes? In a stress response, do your pupils dilate? Now, when your pupils dilate, that means more light can go through? Or do your pupils constrict? You ever seen the pupils dilate and constrict? When you shine a bright light on your eye, the pupils will get smaller. When you enter a dark room, the pupils will get bigger. Okay? So, what do you think happens in a stress response? Do the pupils dilate or do they constrict? Why, Anika? Why do they dilate? You guys are on fire today. Why do they dilate? If your pupils dilate, does more or less light come in? More light. So why would you want more visual information in a stressful scenario? Yeah, so you can see better, right? So you can get more visual input. So we would expect then, like your pancreas, your stomach, we would expect that to decrease in function because that's part of your digestive system. Okay. All right. Okay. So we okay with then how the two systems work together, how they're antagonistic? Okay. I'm going to come back to this, okay? See if you guys understand. Because I'm going to talk about some chemicals, and I'm going to see how they affect the systems, all right? So I'm going to skip down to the section here on chemicals, okay? And I'm only going to talk about some of them, all right? So I have a list here of chemicals that affect the nervous system. And we'll talk about how some of them work, okay? Like, for example, you ever hear of endorphins? Those are like natural painkillers, okay? Here are some other chemicals. So, like, for example, cocaine stimulates the release of epinephrine. So what would that do to your heart rate? It would increase it. Valium, on the other hand, increases the effectiveness of GABA. So what would that do to your nervous system? Would it increase your reaction time or decrease your reaction time? Now be careful how you think about that. When you say decrease your reaction time, that means your nervous system is actually working quicker. So let's just make it simple. Would it enhance your nervous system? Would you be able to respond to things more quickly? Or do you think you'll respond to things more slowly? Because if your reaction time takes longer, that means your nervous system is slowing down. So what do you think Valium does? Do you think it excites the nervous system, or do you think it calms it down? Emily? Calms it down, okay? So sometimes people are prescribed Valium because they're like very stressed out, high anxiety, and someone will say, take a Valium. If someone says to you, take a Valium, it means they're basically saying, calm down. Okay. I'm not, by the way, endorsing drug use here, okay? I'm just letting you know if you hear that. Okay. Ethanol has a very similar effect. Ethanol actually also enhances GABA. That's why if you're driving and you've had a few drinks, your reaction rate is slower. Your reaction time is longer. Takes you longer to react to things. So it's not a good idea to be driving while you're drinking, because there is a negative effect on your nervous system. Botox. You've heard of Botox, right? Okay. So it comes from a bacteria, botulinum. Okay. Now, the toxin inhibits the release of acetylcholine. Okay? So it prevents the release of acetylcholine. Why would a patient then who has this toxin experience dilated pupils? Why would they have dilated pupils? What's not being released? Okay, so acetylcholine is part of the sympathetic or the parasympathetic? Which one? Yep, it's involved. It's part of the parasympathetic. So, if we're not releasing the neurotransmitter from the parasympathetic, remember the parasympathetic wants to do what to your eyes? Dilate or constrict? Constrict. So if that chemical is not being released, then we cannot constrict the pupils. Therefore, they will remain dilated. Okay. Oops. Okay. During World War I, they started to use chemicals for warfare. You probably hear about this in the news. They use chemicals. Biological warfare is using so this biological warfare, we're using things like viruses and bacteria to kill people, and then this chemical warfare, where you're using chemicals like nerve gas. Okay. So we started seeing chemical warfare in World War I, probably before that, I would imagine. Biological warfare has been going on for hundreds of years. I know in the Middle Ages they would throw bodies for people who had plague into cities. So we'll talk about that maybe if you guys remind me when we get to the immune system. So during World War II, they developed a nerve agent called sarin. There's actually a few versions of this. Now, what this nerve agent does is it inhibits cholinesterase. Okay? Now, what the effects are in a person who has this nerve agent poisoning is pupils contract, person starts to undergo convulsions, which the muscles are contracting uncontrollably. The person will increase salivation. They'll start to pee themselves and also poop themselves, and then they'll stop breathing. Why? Why? How come? Well, look what it's inhibiting. It's inhibiting an enzyme called cholinesterase, or acetylcholinesterase, right? Now, do you recall when the acetylcholine is released, what has to happen to it? Do you remember? If you go back to the way a neurotransmitter works, and we looked at this example, right? When acetylcholine is released, It binds to a receptor and either promotes an action potential or it doesn't, right? So if acetylcholine promotes an action potential, what must happen to the acetylcholine after it does its job? It must be what? Removed. Okay? And the enzyme that removes it is called cholinesterase or acetylcholinesterase. So that means if the enzyme cholinesterase is inhibited, then acetylcholine stays. So remember, acetylcholine is part of which system? Sympathetic or parasympathetic? Parasympathetic. So let's see if we can figure out that. So if we can't remove the acetylcholine, then let's see if we can figure out why we have these problems. So, can't get rid of the acetylcholine. So what happens to the pupils? Pupils will what? Contract, because now you have all of this acetylcholine which you can't get rid of. Acetylcholine is part of the rest and digest system, the parasympathetic. So we expect increased salivation. We didn't talk about the role on your bladder and your anus, but obviously this would increase the movement of certain things out of your body. Okay. Why does it affect your muscles? Because that's what convulsions are. You have these muscle contractions that you can't control. What's the stimulus for muscles? What's the chemical that stimulates skeletal muscles? So if you take a look, we get to the somatic nervous system. What's the chemical that stimulates skeletal muscles? It's acetylcholine. So acetylcholine is part of the somatic system. It's also part of the parasympathetic system, right? So if there's too much acetylcholine, we can't get rid of it. That means your skeletal muscles will be stimulated uncontrollably. So we could see then the effects because we can't get rid of the acetylcholine. Asphyxiation is what happens in asphyxiation? Person stops what? Well, you can't breathe properly, right? Because remember, you have to get rid of the neurotransmitter so you could what? Recharge, right? The cells need to recharge. So if you can't get rid of the neurotransmitter, that's not going to happen. Okay, I think that might be it. Oh, one last one. Let's talk about the black widow. Okay, the black widow. You know what a black widow is, right? Spider. It's got this nasty bite. The black widow has a toxin called alpha-latotoxin. And what it does is an interesting one because I only thought it only promoted the release of one neurotransmitter, but it actually promotes the release of many neurotransmitters. The way it works is the toxin actually promotes the entry of calcium. And if you remember the way neurons release stuff is they have to have what's called a calcium spike. So when calcium levels go up, the neurons release their neurotransmitter. So here are some of the symptoms that you get from black widow toxin. Now you'll notice down here, so we have tachycardia and bradycardia. Now, do you guys know what that refers to? If a patient has tachycardia, you know what that means? It means the heart rate is too high. And bradycardia is the opposite of that. How can you have both? How's that possible? How could a patient with black widow toxin poisoning have maybe, some people might have bradycardia, some people may have tachycardia? That doesn't sound normal. That sounds kind of weird. And the answer is because if you look at the toxin is not promoting the release of one neurotransmitter, it's promoting the release of many. And if you remember, what does acetylcholine do to your heart? Does it stimulate it or does it slow it down? Do you remember? And this is the last thing we'll look at, and we're done. Well, if the sympathetic system increases the heart rate and uses adrenaline, then the parasympathetic, which uses acetylcholine, should decrease the heart rate. So because the toxin promotes the release of acetylcholine and adrenaline, acetylcholine will lower your heart rate, adrenaline will raise your heart rate. So you could see why in some cases you'll have elevated heart rate, in some cases you'll have decreased heart rate, because both types of neurotransmitters are being released. Okay, ladies. So look, that's basically the survey. We started with neurons, and then we talked about the actual system as a whole and how it's affected by certain chemicals. Again, there's not going to be anything on the brain. Okay, I'm not going to test you on the brain. We will do a dissection, but I'm not going to actually give you like questions about parts of the brain. So I think we'll end there. Okay, ladies, that is it.